Hey, how's it going everyone? JP here. I'm back with another Leetcode solution, this time to question 11, container with most water. Before I get started, if you guys want to support the channel, you guys can sub as well as like this video. It helps a lot and I appreciate it. Okay, so yeah, without further ado, let's get started with the question. Alright, so in this question, we're given an integer array called height. And each of the numbers or each of the integers in this array can represent a wall of our container. And what we need to represent or what we need to return is the max amount of water that we can pretty much capture in this container. Okay, so one thing I should note is that we need to have a container that does not slant. So this right here. Right? We cannot slant the container. What does that mean? Well, let's just say we had a container with two walls. One, let's say this is being 8, and then the other one being 2. Right? We cannot have the container hold water such that the water is held like this. Right? So the water cannot, be slanted. Right? That's not possible. Instead, what we need is we need to have our container hold the water such that the top is flat. Right? So instead of looking like this, right, we have a container that holds water, let's say like this, right? So that's basically what it means by we cannot slant the container. Okay, so now that I got that out of the way, let's take a look at, that did not work. I'm trying to erase this, give me a second. Okay, so what I'm going to do is I'm going to walk through the first example and let's see how they got the solution. So here we're given the heights, right? We're given 1, 8, 6, 2, 5, and all those. And the cool thing or the good thing about this is that it gives us a visual of what it looks like. And we can already see that the walls that they used is this one here and this one here. So the left wall has a height of 8 and the right wall has a height of 7. And if you notice that since we cannot slant the wall, we must take the wall, you must take the smallest wall between the two, because that way we can guarantee that the top will be flat. And another thing we need to note is that the base of the container is going to be the distance between the left wall and the right wall, right? So this is going to be the distance or the base, right, of our container. And in this case, it's going to be 7. And you can actually see the output here. So the max area of the container is going to be 49. And you can clearly see where that comes from, right? If we take the minimum between 8 and 7, we get 7. So that's going to be our height. And then if we take the base, which is also 7, and we multiply that, we get 49, right? So that's how they get the solution. So let's actually take a look at a possible approach to this solution, right? So how can we get these numbers? How can we get the base? How can we get the walls? And then of course, how can we return the max area? So what I did here in advance is I just wrote up the array with as well as the indices as in the first example. So one way we could do this is by using 2 pointers. And by using 2 pointers, we can have one stationary at the beginning, or I guess starting at the beginning. And then the second pointer can iterate through the rest of the array, right? So we can have this 8. And then while we're iterating, we can keep track of the maximum area just by updating it every single time we move the second pointer, right? So if we move the second pointer, we can calculate, is this a new maximum? Is this, is this a new maximum area? Yes. Okay, let's update that global variable. If it isn't, let's just move on. And The problem with this approach is that it's going to take big O of n squared, namely because we are visiting each of the numbers at least twice, right? Except for the front and the end, but that doesn't make a difference. The point is that it's going to take big O of n squared, and that's not very efficient. Now we can still use this two-pointer method but instead of having one stationary and have one move throughout the rest of the array, we can actually have one start at the beginning of the array, and then another one starting at the end of the array. And what we can do here is we can update the pointers depending on which one is the smaller one, right? So what we can do is, okay, well, if we have, again, we're still gonna have that global max area variable, which we're going to update every single iteration. But basically what we're going to do is we're going to calculate the area, and then every single time, or at the end of the calculation, we can check two things. We can check or we can check a thing, basically, is the left wall or the right wall smaller? Whatever is smaller, we need to iterate, or we need to decrement, or yeah, increment or decrement. In this case, we can see that the left wall is smaller, so we're going to increment the left pointer, and we calculate the area again. And then whatever wall is smaller, we're going to move that pointer. So in this case, the right pointer is smaller, so let's decrement it down. And we can keep on doing this, right? We can keep on decrementing until we get the two pointers to meet each other. So once, let's say here, right, eventually the left and right is going to meet each other, and that's where we stop, and then we just return the maximum amount, or the max area. And you can see that this reduces the time complexity to big O of n. So instead of big O of n squared, we reduce that to linear time, which is a lot more efficient. And this is probably the solution that's probably the most efficient. If not, actually leave a comment below if there's a more efficient solution. Yeah, okay. All right, so let's code this up. Let's code up the solution. So first of all, let's create that global variable. Let's call it max area. So that's 0. We also need to establish the two pointers, right? The left and right pointer. So the left and right pointer is going to be, or the left one's going to be at 0. And then the right pointer is going to be at the end of the list, right? So like that. And then we need to create a condition that allows us to pretty much keep going until we reach, or until the two pointers meet. So that's going to be our while loop here. So while left is less than our right. So what we do now is we have to calculate the length, right? The length of our wall, or I guess the length of our container, or the height of our container, I should say. So let's say our height, right? So let's say our height, which I'll denote as h, is going to equal the minimum between our left and right wall, right? So height, and then our left wall, and then our right wall. And then our base, so I'll denote that with b, is going to be the difference between our left and right, right? Or our right and left, I guess. And then one thing we're going to do is calculate the max. So we're going to say, I would say current area is going to equal, sorry, not the current area. Actually, yeah, current area can equal our height times our base. And then what we need to do is we need to update our max area. So we say max area is equal to maximum between our current area and our max area, right? Because every single time we calculate our current area, we always want to check whether or not our current area is the maximum, or is it our previous maximum area. So we're going to update that. Okay, so once we do all that, we need to now increment or decrement the pointers depending on which one is smaller. So we could say if the height, right, if the left If the left wall is smaller than the right wall, then we need to increment the left wall or the left pointer, right? So we do L plus equal 1. Otherwise, right, we need to increment or decrement the right pointer. So R is decremented by 1. So here we could just say that if this is true, where the height is smaller or the right wall is smaller, then we decrement the right pointer. Now, once this loop breaks, right, that means that the left and the right pointer are beside each other. And at that point, we can just return the max area. Okay, so let's run the example cases. So you can see here it passes. So this is the first example. Now let's run it against the other test cases. As you can see, I already did this question quite a number of times, but you can see that it runs and it works. It runs pretty efficiently, and it doesn't use any extra memory. So before I end, let's actually document the runtime. So, the runtime of this algorithm is going to be big O of n, right? So linear time, and the space is going to be a big O of 1, right? Constant. So again, the reason why it's linear is because we're only going to visit each element once, right? We're never going to visit the same element twice, which is why it runs in big O of n. And the reason why it's constant time, it's because we only keep track of the max area, right? That's the only extra space that we need, and it's just a constant. So that's why it's big O of 1. All right, so that concludes this video. If you guys do enjoy this type of content where I solve Leetcode questions, support the channel. Like the video as well as sub to the channel. And if you guys want to see other questions being solved, leave suggestions and maybe I'll solve them in the next one. Yeah, so that's all I really have for today or for this week. Yeah, I'll see you guys in the next video. All right, later.